This is finding the instantaneous rate of change. There's 4 or 5, I believe 5 word problems, and it involves using the derivative. So we're going to find the surface area of a sphere. No, this is the wrong one. Let's go back. Stop. Okay. So we're going to find the instantaneous rate of change, and the first thing we're going to do is find the volume of a right circular cone with the height equals 6 feet and a radius r feet, and the formula is given. I went ahead and put in the height here, so our formula now is 2 pi r squared. So if r is changing, find the instantaneous rate of change of the volume with respect to the radius, which equals 3. So what we're going to do is take the derivative of the volume of v with respect to 3, and we're going to take the limit as x approaches 3. Instead of f, we're just using f of r. Usually we use x, we're going to use r minus the evaluate 3 over r minus 3. Now this equals 2 pi r squared minus 18 pi over r minus 3. And that's this should include the limit in front. The limit as x approaches 3, I'm going to factor out a 2 pi of the numerator, and I'm going to get r squared minus 9 over r minus 3, which equals 2 pi times r minus 3 times r plus 3 over r minus 3. That cancels, and all you do is evaluate. So we're going to take the limit as x approaches 3 and plug in r 3 for the r, and that gives us 12 pi, which is approximately 37.699 cubic feet per 1 foot change in the radians. This is per 1 foot change in the radius. Okay, there's 4 more word type problems that are very similar, and I'm going to squeeze them in like I did here. I think I have a little extra, no, not really. So basically we're going to find the instantaneous rate of change. Basically we're going to find the derivative, and we're going to find the instantaneous rate of change of the volume with respect to the radius r equals 3. So basically this is going to be volume of r, the derivative of the derivative of the volume with respect to 3 equals the limit as r approaches 3 of the volume of r minus the volume, evaluate the volume of 3 over r minus 3. And that's going to give us the limit as x approaches, or r, keep wanting to do x, 3, and we just copy down the formula, and this is going to be, when you evaluate the 3, you're going to get 3 pi r squared minus 27 pi. I just inputted the 3 into the radius here for r minus 3. Now we're going to factor out the 3 pi, and we get r squared minus 9 over r minus 3. So that gives us 3 pi times r minus 3 times r plus 3 over r minus 3. That cancels. So the limit as r approaches 3, gets closer and closer to 3, of 3 pi times r plus 3, plug in 3, and that's going to give 3 pi times 6, which is 3 plus 3 is 6, so that's going to give us 18 pi. And so at the instant, sorry my handwriting's bad, but it is. At r equals 3 feet, the cylinder, so this is a cone, okay. The cylinder is increasing at a rate of 18 pi cubic feet per second. This is cubic feet. Okay. Now the next one is we're going to find the instantaneous rate of change with respect to the volume and with respect to the radius r equals 2. And here's our formula for the volume of a sphere. So I'm going to take the derivative of the volume at 2 and by taking limits as x approaches 2, the volume of r minus the volume of 2 over r minus 2, and this is going to yield 4 pi r cubed, this is 4/3 pi r cubed, minus, and now I'm evaluating at r equal 2, I'm plugging that in, and you're going to get 32 over 3 pi. Okay, I'm going to factor out, take the limit again, I'm going to factor out 4/3. This is all over r minus 2. And we're going to get, I'm actually going to factor out 4/3 pi, because they both have pi in the term. So we're going to get r cubed minus 8 over r minus 2. Now I have this difference of the cubes, so I'm going to factor that out some more. So that's 4/3 pi times r minus 2 times r squared plus 2r plus 4 all over r minus 2. Now you cancel that out and you take the limit as x approaches 2 of 4/3 pi times r squared plus 2r plus 4. And when you do that, plug in 2 for the r, you're going to get 16 pi. And what this means is at that very instant that r is 2 feet, the volume for the sphere is increasing at a rate of 16 pi cubic feet per foot. So I'll say it again. At the instant r is 2 feet, the volume of the sphere is increasing at a rate of 16 pi cubic feet per foot. Okay, now we're going to talk about a volume of the cube. So basically, we want to find the instantaneous, the instant that x is 3, that the volume of the cube is increasing at the instant x is 3 meters. All right? So basically, we're going to take the derivative of the volume with respect to 3, and this equals the limit as x approaches 3 of the volume of x minus the volume of 3 over x minus 3. Okay, and this equals the limit as x approaches 3 of x cubed, because that's this part, that's this, and then I plugged the 3 in and I got 27 over x minus 3. I use my difference of cubes formula. I'm going to get x minus 3 times x squared plus 3x plus 9 over x minus 3. Cancel that out. Take the limit as x approaches 3 of x squared plus 3x plus 9. And that's going to yield 27. So at the instant x equals 3 meters, the volume of the cube is increasing at a rate of 27 cubic, write this down, cubic meters per meter. Okay, now the last one I have has to do with the surface area of a sphere, and the formula is 4 pi r squared, and we want to find the instantaneous rate of change of the surface area with respect to the radius r equals 2. So let's determine what we're finding. At the instant r equals 2, we want to know where the surface area of the sphere is increasing at what rate. So we're just going to take the derivative with respect to the surface area. So the derivative of the surface area with respect to 2 for our radius equals the limit as r approaches 2 of s of r minus s of 2 over r minus 2. So you just plug everything in. This equals the limit as r approaches 2. S of r is 4 pi r squared minus 2 squared is 4. 4 times 4 is 16 pi over r minus 2. Factor out 4 pi, and we're going to get r squared minus 4 over r minus 2. So this yields the limit as the radius approaches 2 of 4 pi, and you factor r minus 2 times r plus 2 over r minus 2. These cancel. You plug in the 2 here, and you're going to get the limit as r approaches 2, 4 pi times 4, which equals 16 pi. And that's going to be square feet. All right? So basically it means at the instant r is 2 feet, the surface area of the sphere is increasing at a rate of 16 pi square feet per foot, per 1 unit basically, per foot. Okay, the next video I'm going to do talks about the instantaneous speed of a particle, and we're going to be answering several questions about that.